Simultaneous equations. In this clip we will be looking at simultaneous equations again, but this time we will have an extra step. Let's have a look at this example. At the moment, neither the x's or y's have the same coefficient. Therefore, what we're going to have to do is to multiply one or both equations by a number in order to get an equation whose coefficients of x or y are the same. So let's have a look. If we multiply equation 2 by 3, we would get 9x plus 3y equals 18. And therefore we would now have an equation whose y coefficient is the same as the y coefficient in equation number 1. And we rename this new equation number 3. So we will now use equation 1 and 3 to eliminate the y's, as they now have the same coefficient, as you can see here. So now we have the same coefficient for one of the terms, which is our y term. Remember, we need to check the sign. Our rule before said that if they have the same sign, which they do, they're both positive, the rule is to subtract the equations. And we're going to subtract equation 3 from equation 1. So we'll do 4x minus 9x. These terms will be eliminated. And 13 minus 18x. And that will give us minus 5x equals minus 5. Now, as you can see, by subtracting equation number 3 from equation number 1, we've been left with two negative terms. We have minus 5x and a minus 5. Now what we could have done instead is, instead of doing 1 minus 3, you can just as easily do 3 minus 1. Now if we do 3 minus equation number 1, we get 5x equals 5, which will then give us x equals 1. Now if we did have minus 5x equals minus 5, we would have just divided both sides by minus 5, and that would have given us x equals 1. Now if we had been left with minus 5x equals minus 5, we would have just divided both sides by minus 5. We would have still got the answer of x equals 1. But it's just easier whenever you don't have to work with negative signs. So now that we have x equals 1, we're going to substitute x back into equation number 2. So 3 times 1 is 3, and then we subtract 3 from both sides, so then that will give us y equals 3. Then we're going to check in equation number 1, and that will give us 4 multiplied by 1 plus 3 multiplied by 3, and that does equal 13. So my two solutions are x equals 1 and y equals 3. Now in this example you can see that neither the coefficients of the x's nor the coefficients of the y's are the same. Also, there's no way, if we were to multiply just one of the equations by a number, would we get x's and y's to be the same. So therefore what we will do is we're going to multiply both equations by a number in order to get the coefficients to be the same for one of the terms. So we will multiply equation 1 by 3, and then we'll multiply equation 2 by 2. So multiplying equation 1 by 3, we get 6x plus 9y equals 24, and multiplying equation 2 by 2, we get 6x plus 10y equals 28, and we have numbered these two new equations 3 and 4. Now, as you can see, we now have the x coefficients both 6. Now our rule is, if the coefficients of the terms we're trying to eliminate are the same signs, which they are, they're both positive, that means we're going to subtract the two equations. So I can do equation 3 subtract equation 4, but it's going to be easier to do 4 take away 3. So 6x minus 6x will give me nothing. Those terms are eliminated. Then 10y minus 9y is 1y, and 28 take away 24 is 4. So we have y equals 4. So substituting that back into one of our original equations, equation number 1, we get 2x plus 3 multiplied by my y value of 4 is 8, and then we multiply out to get 12, and then we subtract 12 from both sides to get 2x equals 6, and then we divide both sides by 2. So we get x equals 3. So don't forget, the very important last step is to check both your x and y values into one of the other equations. We'll check into equation number 2, one of my original equations. And we have 3 times minus 2 plus 5 times 4, which is minus 6 plus 20, which is in fact 14. So that is correct. And my values are x equals minus 2 and y equals 4. Here's another one to try. As you can see, neither the x coefficients or the y coefficients are the same, and there's no way we can just multiply one of the equations to get the coefficients the same. Therefore, we're going to multiply both equations by a number. So what I've chosen is to multiply the first equation by 5 and the second equation by 2, and doing so, that will give me the same coefficients for the y's. Alternatively, I could have multiplied the first equation by 4 and the second equation by 3, and that would have given me the x coefficients the same. Now multiplying the equations, I get 15x minus 10y equals 20, which I number equation 3, and 8x plus 10y equals 26, and number that equation 4. The coefficients of the y terms are the same, so these are going to be eliminated. However, I need to check their signs, so they're different, therefore that means I will add the two equations. So adding equations 3 and 4, that will give me 23x equals 46, as the y terms have been eliminated. Then I will divide both sides by 23, which will give me x equals 2. Then I'm going to substitute x value into equation 1. And then that will give me 3 multiplied by 2, which is my x value, minus 2y equals 4. Then I'm left with 6 minus 2y equals 4. Then I need to get the y's by themselves, so I will subtract 6 from both sides. So minus 2y equals minus 2. And then the very last step, to get y by itself, to find the solution, I divide both sides by minus 2. So I get y equals 1. Now I need to check, so I'm going to check in the other equation, the other original equation, which is equation number 2. So I've got 4 multiplied by my x value and 5 multiplied by my y value, and that indeed gives me 8 plus 5, which is 13. So my solutions are x equals 2 and y equals 1. Not sure, turn to answer some questions. Pause the video, then try these. How did you get on? Here are the answers. If you answered any incorrectly, have a look back through the video and then try again.